じゃあ、皆様、はじめまして。僕は大体日本には4年間に住んでました。その時に変圧器遮断機の技術して、で、今日の発表は英語で、けど問題あれば後で日本語で頑張ります。よろしくお願いします。はい。So, today's presentation is in English. So, I would like to start with some more pictures. I think the Swiss tourism should also sponsor this event. As you can see, also live in the area of Lucerne. We have a lot of sites, we have a lot of tourists, but actually the city itself is comparably small. It's only about 80,000 inhabitants, and we have 1.4 million overnight stays in that city, so it's very popular. But it's not only about the beautiful sites, we have also a lot of industries, and these industries need electric power. And I'm with CKW. CKW supplies electricity for the whole area of the central Switzerland. And we are part of the Axpo Group. CKW itself has around 2,000 employees. The Axpo Group is the largest utility, around 7,000 employees. I would like to talk about grids. So you can see here, this is today. So we have around 800 megawatt of power. From this 800 megawatt of power, 400 megawatt is on the higher voltage level. So there are data centers, large-scale customers, steel works, and so on. But the other part, the other 400 megawatt, are the households and the inhabitants and industries in our area. And it's rather difficult to talk about them because there are not so many data available compared to the large-scale industries. And I would go a little bit into that data and show what could happen in the future. We also have around 375 megawatts of PV installed, and this matches almost the demand nowadays in a peak day. So what happens now? Today we heard the representative from the Swiss Federal Office of Energy. This office also provides some scenarios how the future will develop, and applying this scenario to the PV, probably we end up around 1,100 megawatt in that area. About households, I assume that it will be more or less the same, maybe more dense, but also a little bit more efficient. So let's say the consumption will be more or less the same. We hope that we will not be deindustrialized, so that we still have a good part of industries in our region. And what's upcoming next are the heat pumps. We like them because they are like a band. And it's the electromobility. And the electromobility is a challenge for us. We have this is just a brief calculation by thought, around 250,000 cars are registered in that area. So if everybody has an 11 kilowatt charger at home and calculates that by charging all at the same time, it would end up by 2,750 megawatt. Of course, not everybody is charging at the same time. That will not happen. But let's assume that there is once a situation during the year that every 10th car is charging in the wintertime. Then we have an additional 300 megawatt on top. And it's also a difference between higher voltage level and lower voltage level. The less you consider, so the lower, for example, in the street, it's not unlikely that probably every fifth car is once charging, that there is a situation here that every fifth car is charging. So what we see at the end is that the load increases and the supply increases significantly, almost triple. And we have to consider that in our planning. So, of course, this is a glass ball, and the look in the future, we will see what the future brings, but we have to be aware what could happen. And there are two solutions, basically. We can reduce that, and we reduce the load, and we can also combine the two effects in order to meet supply and demand as well. And I want to explain what we actually do for these three phenomena currently. So regarding the heat pump, I think we could, as a quick win, apply an existing system that we already have. So in Switzerland, usually the water is boiled. They have a water tanks in each house, and that's heating and storage, store the energy of the water. And what we do actually, we do stagger these heat pumps that not everything is at the exact same time charging at the moment, for example, in the morning when the people want to shower. And so this staggering leads to a more or less stable load flow. And we also consider some threshold which we prevent the heating of the system. And the same system could be applied to heat pumps because there is some latency in the heat development on that. So I think that would be a quick win for the first step for the heat pumps. About electromobility, it's a bit more complicated. You see a lot of analysis based on fast charging stations, but what we actually do is we have 200,000 smart meters in every household, and we analyzed the data. We first anonymized it, then analyzed it, and came up with that picture, and I hope it will work. Yeah, coming closer to that. So, so this each dot you see is like a charging cycle from a car. And personally, I'm not happy about that because it's like a pulse. So you see an extrema in the charging situation. And you can make a normalization of that data, which is shown at the left graph over there. And you see a clear peak at 9 o'clock in the evening. Does anybody know why it is at exactly 9 o'clock? Is there a reason for that? Miss Tima, yeah. Tariff change. Actually, it's not the overtime, not the Zangyo, it's the tariff change. We have two tariffs during daytime and nighttime. And of course, the customer adapt to that. They see at nighttime it's cheaper, so they program their charging computers to load at the evening because it's cheaper. So what we do is we get rid of these two tariffs. So we just make one tariff for the whole day. And what we do, we charge the maximum peak. And this is currently in place. And we want to motivate the customer to distribute their use of electricity in order to minimize the cost of grid investments and also to minimize the cost for the customer itself at the end. What we also have to consider, this fast charging station can be, we made some simulations, up to 50% of the load. So we have to be aware of that. And there are other partners involved, so like Tesla and so on. So we have to negotiate about that, how to improve that. I saw an interesting approach in Amsterdam. So they used the power according to the sunshine. So if the sunshine is high, they can charge at maximum power. If the sunshine is low, they limit the maximal power. So that could be an interesting approach. What we also do actually right now is to use a board controller of the cars. The cars are connected with the mobile phone, and voluntary customers are using this system. And what they do, if there is a critical grid situation, the car will not charge. So we use the existing controlling infrastructure in order to control that. About photovoltaics. So now you see the full picture. I mentioned 800 megawatt. This is 2021 and there is 2025. So you can say the winter load is almost the same. It did not change so much. A little bit increased, but not so significantly. However, the summer peak during PV increased significantly. And these are, of course, actual data. You can see that in 21 it was more or less zero. And in 25, we had a situation where there is over 200 megawatt return into the transmission grid. And unfortunately, when the return on the transmission grid is, the market prices are also negative. So we have to buy from the customer the energy, and we have to return it to the transmission grid and pay again that the transmission will take it. So we have to be aware of that. And there are two approaches. From next year, 2026, there will be a new law in place in Switzerland. So we have the opportunity to reduce the energy production at the end customer at 3%. 3%, however, reflects about 70% of the panel peak power. So there are only few times during the year where there's really full capacity of the photovoltaics. And so if we limit that at 70%, we could save tremendously amount of investments into the grid and also allow other customers to add additional PV panel, which produce then in these hours where the current is much more, the energy is much more worth. A second approach is illustrated below. There is a correlation between the grid load in medium voltage, high voltage, as well as low voltage, and the market price. So if the grid load is high, the market price is also high. And this correlation can be used to make a dynamic pricing. So for example, instead of a stable price, we could offer the customer a dynamic price. He take the price and the controller unit at his house decides what he does with the energy. If he charges the car, if he uses a battery, or if he just return it into the grid because there is not enough supply. A last slide, and then I think I'm very well in time. Bringing things together, of course, the first approach is always to use batteries. That's clear. But we want to consider as another effect all these players you saw recently. There are new players in a market, and they provide flexibility. They can turn off their PV, they can turn off their car or charge their car, they can use a battery. So there is a lot of more flexibility in the grid. And what we want to do is together with Swissgrid is the transmission grid operator and initiated this project with other utilities, build a flexibility market where you can use your flexibility and get money for that, for your acting on that market. And I think that would be a good idea as long as the market becomes big enough to be prosperous. Yeah, so thank you very much.